Concave? Convex? How do images form in lenses? Hello, Sir Pals! I am Ma'am Josephine Padua, your science teacher for today. In this episode of Agham Alam Hub, we are going to study lenses and its type. We will also discuss and apply the ray diagramming techniques and steps in describing the characteristics and positions of images formed in lenses. Furthermore, we will appreciate the importance of the application of lenses in optical instruments. In the next few minutes, we will explore science for another moment. Images are formed when light refracts as it encounters a boundary between two different materials. Look at this pencil in water. Do you know that what you see is not exactly a crooked pencil, but instead the image of the pencil formed by refraction? Amazingly, we have a sense of sight due to refraction through two boundaries. Our eyes have lenses that create images that enable us to see the objects. But have you seen a lens? How will you describe it? That's right! A lens is a transparent material that refracts light to form an image like glass and plastic. There are two types of lenses, the converging and diverging lenses. A converging lens is a lens that is thicker in the middle than at the edge, and it is also known as a convex lens. On the other hand, diverging lens or the concave lens is thinner in the middle than the edge. Lenses can form images that are real or virtual. The real images formed by lenses are inverted images that can be seen by projecting them on a screen. In comparison, virtual images are upright images that are seen directly from the lens. But to understand lenses, let us first discuss their parts. If symmetrical lenses were thought of as being a slice of a sphere, then there would be a line passing through the center of the sphere and attaching to the mirror in the exact center of the lens. This imaginary line is known as the principal axis. A lens also has an imaginary vertical axis that bisects the symmetrical lens into halves. Vertex is the optical center or the geometric center of the lens. Light rays incident towards the lens face, the traveling parallel to the principal axis, will either converge or diverge. This intersection point is known as the focal point. The focal point is denoted by the capital letter F. Note that each lens has two focal points, one on each side of the lens. Unlike mirrors, lenses can allow light to pass through either face, depending on where the incident rays are coming from. Subsequently, every lens has two possible focal points. The distance from the mirror to the focal point is the focal length, abbreviated by the small letter f. Technically, a lens does not have a center of curvature. However, a lens does have an imaginary point that we refer to as the 2F point. This is the point on the principal axis that is twice as far from the vertical axis as the focal point is. To graphically determine the position and characteristic of the image formed in lenses, the ray diagram can be used. There are some special rays we can use in the ray diagramming of the lens. These are PF ray, FP ray, and V-ray. Ray diagramming technique is somewhat tricky since these three special rays are quite different in convex and concave lenses. Let us first discuss how to draw these three special rays in the convex lens. PF ray is a ray of light parallel to the principal axis and is refracted, passing through the principal focus behind the lens. FP ray is a ray of light passing through the focus in front of the lens and is refracted parallel to the principal axis. V-ray is a ray of light passing through the exact center of the lens or the vertex that continues to travel in the same direction. To find out the images formed in lenses, follow these steps. From the tip of the object, draw the PF ray. From the same point on the object, draw the FP ray. And lastly, still from the same point on the object, draw the V-ray. The intersection of the rays is the image point corresponding to the object point. For instance, if you started diagramming from the tip of an arrow-shaped object, the intersection of the refracted rays is the tip of the image of an arrow-shaped object. Images formed in lenses are qualitatively described according to location, orientation, size, and time. The location of images may fall at points identified along the principal axis, such as at the focus F, at twice the focus 2F, between F and 2F, between F and vertex V, or beyond 2F. The orientation of the images may be described as inverted or upright. The size of the image compared to the object may be reduced, enlarged, or the same size, and the type of the image can be real or virtual. Knowing all of this, we are now ready to describe the images formed in lenses using a ray diagram, using an acronym LOST. L for location, O for orientation, S for size, and T for the type of image. Let us have an example. In front of a convex lens, the object arrow is placed beyond 2F. What is the first step in the ray diagram? That's right. We will draw the PF ray from the arrow's tip parallel to the principal axis, and it's refracted or bent through the focus behind the lens. What about the next step? Correct! We will draw the FP ray from the arrow's tip passing through the focus in front of the lens, refracted parallel to the principal axis. What's next? Correct! Draw the V-ray from the tip of the arrow passing through the optical center or the vertex of the lens. Remember, this ray does not appreciably refract. Now, let's find out the intersection of the three rays and draw the image of an arrow toward the principal axis. What do you notice about the image? That's right, it is located between F and 2F. Orientation is inverted, the size is reduced, and the type of image is real. Let's have another one. This time, the image is found at 2F. First, draw the PF ray from the tip of the arrow. Then draw the FP ray followed by the V ray. Now, let's find out the intersection of the three rays and draw the image of an arrow toward the principal axis. What is the location, orientation, size, and type of the image formed? Correct! The image is located at 2F behind the lens. Orientation is inverted, its size is the same as the object, and its type is real. It is now your turn. Using ray diagram in the convex lens, describe the image formed if an object arrow is placed. Number 1, between 2F and F. 2, at F. 3, between F and the vertex. Always remember that in a convex lens, images can be real or virtual, reduced, enlarged, or the same size as the object, depending on the location of the object in front of the lens. Let's move on to the concave lens. The three special rays in the convex lens are almost the same in the concave lens, with a few minor tweaks. This is how you will draw these rays in concave lens. PF ray is a ray of light parallel to the principal axis and is refracted as if passing through the principal focus in front of the lens. FP ray is a ray of light directed towards the focus behind the lens and is refracted parallel to the principal axis. V-ray, like in a convex lens, is a ray of light passing through the exact center of the lens or the vertex that continues to travel in the same direction. Now, let us apply this in finding the location of the image when an object is placed at 2F in front of a concave lens. First, draw the PF ray from the tip of the arrow. On the same point, draw the FP ray. Then draw the V ray. Like in a convex lens, the intersection of the reflected ray is where the image is formed. How will you describe the image form? That's right, the image is located between the F and the vertex. Its orientation is upright, its size is reduced, and it is a virtual image. Do not forget that no matter where the object's location is in front of a concave lens, its image is always upright, smaller than the object, and virtual. Lenses are essential in our daily lives. We can see because of our eyes has a lens that produces an image. All optical devices are part of our everyday life. Many people use eyeglasses while doing their activities. Likewise, magnifying lenses, cameras, microscopes, and telescopes are essential instruments used for a specific purpose. Images are formed when using these devices, following the laws of reflection and refraction. In this episode of Agham Alam Hub, we have learned that image in lenses is formed when light refracts as it encounters a boundary between two different materials. There are two types of lenses, the convex or converging lens and the concave or diverging lens. We have also predicted the images formed in convex and concave lenses by ray diagramming. Images formed can be described based on their location, orientation, size, and type. Finally, we appreciated the importance of the application of lenses and optical instruments. Lenses are often used in eyeglasses, magnifying lenses, binoculars, cameras, microscopes, and telescopes. That's all for today's iPiles. Don't forget to like, share, subscribe, and turn on the notification bell. See you again next week for another moment. Only here in Agham Alam Hub, Palladian's SciTech Portal. Bye!